What's up guys and girls, and welcome to the fourth video in my Python tutorial series. In this video we're going to go over lists and tuples, and basically list is just what it sounds like. If you want to store a collection of integers or strings or booleans, you use what is called a list. And then a tuple is a slightly different version of that, and I'll go over the distinction near the end of the video. Before I begin, I want to know how Python's going for you guys. So if you don't mind leaving a comment down below, just let me know what's challenging for you with Python, or let me know something cool that you've built so far with Python. I want to build more of a sense of a community on these videos, so if you leave a comment down below, that would be awesome. Okay, for this video, we'll be kind of thinking about grocery lists as our kind of what we'll build examples off of. So if we wanted to just create an empty list to begin, I'm going to name a variable grocery list, and if I want to define a list, I use these brackets. So this grocery list now is just an empty list. But let's just initialize a couple items into our list. So let's say I need some more milk. Definitely need some more milk. I'm liking avocados a lot on my toast these days, so we gotta get some more avocados. Let me think what else I need some more of. You gotta think that I gotta get a couple Hot Pockets for the on-the-go meal. So now we have a list of 3 items. We have milk, avocados, Hot Pockets, and I can print this out by just doing print grocery list. And as you can see below, it has all of those items. So that's just like initializing a list with a couple of items. But what's really useful with lists is adding and removing items and kind of being able to dynamically change our list. So what we'll do next is we'll start messing around with this list. Krithi! Krithi!
What's up?
I'm going grocery shopping. Do you need anything?
Yeah, can I eat some Oreos?
Oreos?
Yeah.
Alright, I got you. Alright, so let's say we wanted to add Oreos to our grocery list because I'm a nice guy and we're gonna go do some grocery shopping for my roommate. So we can add Oreos very easily to this list by doing grocery list dot append, and then I can do Oreos. So append means add on. So I did this, and now if I printed out the grocery list, I have 4 items in the list. So even though I just defined it with these 3 items, when I do append Oreos, we now have that 4th item. And so I could keep doing this. Maybe I also wanted some, I have milk, avocados, Hot Pockets, Oreos. I feel like I need to add another healthy option to this. So we'll just do some chicken. Some nice chicken. Get some... You gotta think that we need some eggs. So I can just keep appending to this. So I'm gonna append eggs. So now we have 3 things we appended, and we have the initial items that we declared when we started our grocery list. So if I run this, we have milk, avocado, Hot Pockets, Oreos, chicken, and eggs. So we got a lot of things now in our grocery list. Okay, so now that we have, adding items, let's do the reverse. Let's say we wanted to remove some items. So I'm going to just start, instead of appending these, I'm just going to add these to my initial list. So I'm going to add Oreos, chicken, and eggs. And so let's just say, now I run this, and it has everything still, but I'm now not appending it. I'm just initializing the list to have that. So let's say I wanted to remove something. Let's say I realized that I looked in my fridge and I already had eggs. So I wanted to remove eggs. So I can do the command grocery list dot pop, and this will pop off the end of the grocery list, the last item I added. So in this case, eggs is the last item. So if I run this, eggs is no longer there because I popped it off. So pop is another built-in list function. So we have append, we have the reverse of append is pop. Okay, so we've gone over two basic functions with lists. Now we get kind of into the more, a little bit more complex things. So let's say I have pop, and let's say I realize that I actually also have avocados already. My buddy brought over some avocados from his avocado farm, so I already have avocados. So if I simply just called grocery list dot pop twice, that's not going to do what I want it to do, right? Because it just pops off the end. So I would have to pop a lot of things off a grocery list to get to avocados. So this is where indexing comes in. So we can specify a specific position in the list with indexing. To do this, imagine each item in our list has its own box. And if we want to know like what the position of these elements are, we start counting from 0 upwards. So milk would be at the 0th index, avocados would be the first index, Hot Pockets would be at the 2nd, Oreos would be at the 3rd, chicken at the 4th, and eggs at the 5th. And the key thing to note here is that it starts at 0. It does not start at 1. So even though you might intuitively say, oh, milk is the first element, in Python and a lot of the other popular programming languages, the elements start at 0. So 0 is the first index. So now if I go back to my Python program, I can actually use this indexing to help us out. So we wanted to get rid of, I'm going to just comment these out real quick. So right now I print out grocery list and we have all of these items. I want to get rid of eggs because we already have some. So that's why I do this first pop. And then you see eggs is gone. But I also wanted to get rid of avocados. So now what I can do is I can do grocery list pop, but I can actually put in a number input inside this pop function. So if I go back to that screen, avocados is the first index. So I can just type in pop1. So now if I run this, you see that I have milk, Hot Pockets, Oreos, chicken, no avocados, no eggs, just like we want. So in addition to counting upwards from 0 to 5, we can also count downwards. So I could also start at eggs, and we say that this is the negative first element. Let me make that a little better, that one. Negative first element. Then chicken, we're continually counting backwards. So chicken is the negative second element, Oreos is the negative third, Hot Pockets is the negative 4th, avocado is the negative 5th, and milk would be the negative 6th element. And it's useful to use this negative counting oftentimes because, you know, maybe we don't know how long a list is, and we just know we want to like get rid of the last element or change something to the last element, so we'd use -1 there. Okay, so noting that avocados is now, if we're counting negatively, the negative 5th element, let's go back to our Python code and try doing this pop a different way. So right now we'll just comment out these pops again. We get our full list, as you can see here. Add back in that first pop that gets rid of the eggs, and then we're gonna now do a new pop. So instead of 1, we're gonna try -5. Oh, -5, was that the correct value I said? Oh, okay, so this is a tricky little thing here. So what just happened when I tried to do -5 after the initial pop was once I popped the first time, so I'm going to print out grocery list here. And then I'll print it again after the second pop. So after the first pop, we lose eggs. So if we counted backwards, so we're starting at chicken. Chicken is now -1. Oreos is -2. Hot Pockets is -3. Avocados is -4. And milk is -5. So that's why in the second one, we actually removed milk instead of avocados, because the position of that, the position was no longer the -5th for the avocado. So you gotta be careful when we do this. So one way we could do this, if we wanted to use negative values and get rid of eggs and avocados, is I could do -5 first, and then I could pop off second, just nothing. I just don't put anything there, so that'll take off the last element by default. And as you can see, milk, Hot Pockets, Oreos, and chicken. So that's what we wanted. Cool. And also it's worth noting that if I try to type in a number like 100 in here, we're going to get an error. So you have to make sure you're within the bounds of your list. And if I try to do -200, it would also be error. And also, as I said before, if you look at the, if you look at, if you look at these indexes, 0 is the first element. So remember, it's really important to remember that lists start at 0 as the first position. So starts at 0. So if I wanted to go ahead and, specify that I wanted to pop off the first element twice, I could do pop 0. And as you can see now, only the last 4 things are there. Also, while we're talking about indexing, let's just show how you can get access a specific element in that list. So another thing we can do is if I wanted to just check to see what the second element was in my list. So when I say second, I mean 0, first, second. So Hot Pockets, I could do print grocery list, and then I use brackets here. So if you do the variable of the list and then bracket, and I insert a number inside here, like 2, that is now getting the second index of the grocery list. And the second index is Hot Pockets because we go 0, 1, 2. So if I print that out, I get Hot Pockets. Cool. I can do the same thing with the negative indexing. I can do -2, and this is -1. Eggs is -1. Chicken would be -2, so this will print out chicken. So that's very, very useful if you need to just know what a specific element is. Like imagine instead of a grocery list, this was like a position. That we were building a game and this was a position. So this was like X, Y. So I could do 100, like 300. And if I wanted to know the X or the Y coordinate, so I wanted to know 300, I would just do position and then 1. So this would be the 0th position, so 300 would be the first position. As you can see, we get 300 down there. Also very useful is, in addition to indexing just one element, another thing we can do is we could, let's say I just wanted to get the middle 4 elements of our array. So I could do, we have 6 elements total in this list. So what I could do to get the middle 4 elements is, it's pretty similar to just getting a single element. You do a grocery list, and then you type in the number that you want to start at. So if I wanted to get the middle 4, I would want to start at index 1, which is avocados. And then I do colon, and I continue for however long I want to go until. So this is 0, 1, 2, 3, 4, 5. So I want to include 4. So when we're doing this, the number you put in at the end is the first number we don't want included. So in this case, the first number we don't want included is 5. So that's eggs. So now if I print out grocery list 1 to 5, I get just the middle 4 elements. So that's also very useful. And a couple neat little things about this is if I didn't include a number at the start, it assumes we're starting at the 0th element. So if I do this, we get the first 5. Similarly, if I did 1 and I didn't include the last element, it would know to go until eggs. And you can just play around with this however you need to in your own programs that you write. Then one final thing before I move into some of the more complex functions you can do with lists is we can get the length of the grocery list or any list by just typing in len, L-E-N, grocery list. So I do that, Nothing prints right now because I didn't tell it to print. But if I then print length of the grocery list, make sure you surround it with the proper amount of parentheses, we get 6, which is exactly how many elements there are in here. So that looks good. Okay, let's go over some other useful functions with lists. So first is maybe we wanted to insert an item in a specific location. So let's say I wanted to insert something like, wow, it's hard for me to think of a food item right now, but let's say I needed some silverware. So I wanted just some plastic knives, I don't know. I'll just type in silverware. So I wanted to add silverware inside of here. So, and I wanted it for some reason, I wanted that to be in the top 3 because, you know, if I don't get these items, it's fine, you know, it's not the end of the world. But if I don't have silverware, like how do I eat my avocados? So if we wanted to insert in a specific location in the list, we can do grocery list dot insert. That's another recognize function. And if you want to see all of the recognized functions, I recommend you go to the official Python documentation. So I'll drag that in real quick. So python.org/tutorial/data structures, and I'm on lists right now. So I'm looking at the insert function right now. So insert I, x, and if you see that, insert an item at a given position, the first argument is the index, the element before which to insert. So A0X inserts at the front of the list. This, cool. So I'll close out of that. So insert. So I wanted it right before Hot Pockets, which is the second element, because milk is the 0th. So I do silverware. I do, index first. So 2, silverware. And right now I'm just printing the length of the grocery list. And as you can see, it did increase by 1, but I actually want to print out the grocery list. Not type there, don't type there. Grocery list. And as you can see, silverware is where I want it to be. Cool, cool, cool. And I feel like I had one other thing to say regarding this. Okay, actually, the one thing I wanted to mention is, I'll probably note this a couple times throughout the video, but the reason we're able to directly modify grocery list is because it's known as this mutable data structure in Python. Mutable means changeable. So we can directly alter and dynamically change the list with commands like insert. That's the key difference between lists and tuples, and I'll cover the tuples a little bit more at the end still. But yeah, grocery lists or lists in Python are mutable, so you can change them. You can append to them, you can pop things off. You're allowed to change it. You're allowed to change the variables that are inside the list. And the list can grow as big as you want, and you can shrink it as much as you want. You can have an empty list. Okay, we've done insert. Maybe I'll leave this up. Insert. Another thing you might want to do is, what if you didn't know the index of a specific item? So we can also find the index, or we can find the index by doing the function grocery list dot index. And let's say, I knew I included Oreos in there somewhere, but I don't remember the index of it. I can do index of Oreos. And you have to be careful. I think you'll have to spell this exactly as it is in your code. So now if I printed this, so nothing's going to print from this command because it doesn't actually change the list at all, but I could print this out right here, print grocery list index of Oreos. And also it's going to print out the first occurrence of Oreos. So if you had multiple Oreos in your list, it would only get the first thing. If you want to get inside a specific range, that's in the documentation that I just showed you. So 4, and that's exactly right. 0, 1, 2, 3. Oh shoot, what happened? Oh, I inserted silverware at 2, so that's why it became 4 when we ran this command. All right, that's index. You can also just directly remove something from a list by doing remove. So if I wanted to, actually I'll undo that. If I wanted to remove a specific name of an item, I would do grocery list dot remove Oreos. And if I print out the grocery list, you'll see that Oreos is gone. So that's another function. So we've done insert, index, remove. We have from the start of the video, append and pop. We've covered all of the different indexing of the list too, so you can get like the second and third element. Next we'll switch this up a bit, and I'm gonna delete this grocery list. So all of these functions I'm just gonna delete right now. You can just go back to this point in the video if you forget them, but we're just gonna delete our grocery list. And instead we're gonna do a list of grades. So 100, 34, 72. So there's a lot of functions that are helpful for you with grades as well as with strings. So our grocery list use strings. This is going to use integers. 93, 84, 87, 87, 100, 100, 100. So one person did really bad here with the 34. A lot of people did really good with the 100s. A couple people got 87s. So here are some useful commands for a list of numbers. So the first one is, maybe we were scoring this test. We were a teacher and we were grading this test. It would be helpful for me to put that in numerical order. So I can do grades.sort. And then if I print out the grades, so it begins, so I'll print this out twice. I'll print it before I sort it and after. So this is all inside the documentation. So as you can see, the first time I printed it, it was exactly how I typed it in. The second time after I sorted it, it looks like this. So it's in this nice order. In addition to sorting, we can also do grades.reverse. So if I wanted to go from big to small, and then I print this. So now we have three different things here. We have the way I initially typed it in, we sorted it with the sort function, and then we reversed the sort with the reverse function. Reverse order, sort, and you can, in the sort function, you can like define how you want it to be sorted. Look at the documentations for that. Sort in increasing order. And so one other thing that is very useful is we can do a count of each score. So if I wanted to know how many hundreds got in, and let's say maybe we had 10,000 scores in our list, it'd be annoying to have to manually look through all of those numbers in the 10,000. So if I wanted to just get the amount of a certain value, I could do grades.count of 100. And if I print that out, oh my gosh, what happened? If I print that out, you see 4. That's exactly right. And let's just like play around. So play around with these things. So now I could just pop off a couple scores and guess how many hundreds there are going to be after this. So after we popped off the last two values, we eliminated 2 hundreds, and now I return a different count of 100, which is 2. I could also print out the count of the 87s, which also will be 2. So that's the count function. So we've done, in total in this video, we've done append, we've done pop, we've done insert, we've done remove, we've done index, we've done count, we've done sort, we've done reverse. So a bunch of different functions. You can look at the documentation. I'll put a link in the description to the documentation. But a lot of fun things we can do with lists. Okay, let's end this video talking about tuples, and then also we'll combine everything we've learned in all of these videos for like one last little exercise. So tuples. They're very similar to lists. The way we would write a tuple is instead of using brackets like we do for the list, to write a tuple, we'll say values equals, we use parentheses. So for a tuple, we use parentheses. 12, 12, 12, let's say. We have a tuple of 3 values. And so here's the difference between lists and tuples. 12, 12, 12. Or maybe I'll do like 1, 2, 3 instead of 12, 12, 12. Just so we can kind of have a little bit of separation between the things. 2, 3. So the way I declared values up top is a list, and the way I declared it down below is a tuple. I'll make it a little bigger so you can see it even more clear. And I'll actually name this values list and this as values tuple just to separate them, not have them reset each other. Okay, so we have these two things. We have the list up top and we have the tuple down below. So the first thing about the list is, I've said this before in the video, it's mutable. So all the commands we were doing append, pop, remove, etc. You can do because this type of the list structure allows you to just alter it any way you see fit. The tuple, on the other hand, is called immutable. And basically that means that it's a set object. Once you've set the object the way you want it, the values stored and the structure doesn't change. So it does not change. So for items like, for things that you don't really want to like add to and remove from, that you know they're set in stone, there's these 3 values and that's what you want the values to stay. You don't want this tuple to change around at all. You'd use the tuple to store those. And okay, so I mean one cool thing about the tuple, one way I would probably use this is inside of a function. So I'm just going to delete this list real quick. So let's say we had a function called update, and that took in an x coordinate, a y coordinate, and a z coordinate. Right? I could have a certain rule, so maybe like x equals x plus 5. Like there's some rule you have for how you want these things to update. Maybe you're drawing a line and each time you have a new point, you need it to update a certain way. It like mirrors a slope. Y equals y minus 3 and z equals z plus 10. So we have this update. This is our update function. And what I'll do that uses a tuple is I'll just return the 3 new values as a tuple because they're not going to change until I call update again. But in that case, we have deconstructed the tuple. So I'll return a tuple of x, comma, y, comma, z. And now if I call update, I'm just going to print out update. Print update of, let's say, 10, 10, 10. And we can easily see the change that we should expect. So we expect to see x now 15, y is 7, and this is 20. So if I run this, yeah, 15, 7, 20. And it comes back as a tuple. One nice thing about tuples is it has this kind of feature that you can unpack it, it's called. So if we ran this update function, I could reset x, y, and z to be these new values by doing the following. I can just write x, comma, y, comma, z equals update. And Python knows that, oh, there's going to be 3 values in this update function that it returns. Assign the first value to x, the second value to y, and the third value to z. And now, if I print out x, it knows it's the new value. So we passed in 10 here, but I reset it here using the tuple, we unpacked it, and now we get 15. So it's just something useful to use a tuple for. I feel like when I'm storing and like, you know, messing around with a lot of numbers or a lot of names, I'm usually using a list because I usually want to be able to remove things and add things. So, okay, let's go back to lists really quickly. I just realized I missed one thing that I wanted to say, and that is that if we had a list of grades, so we're moving on from tuples. Tuples, I said all I really wanted to about tuples. Maybe I had some grades again, 95, 93, 80, and 82. Or shoot, 82. Right? So we just have 4 grades here. If I wanted to, maybe one of these students here, one of these 4 students comes up to me and says, Keith, you graded this improperly. I want some points back. So let's say the guy that got an 80, you know, I messed up when I was grading and he should have gotten a 90. So in Python, I can make this change directly to the list by first indexing the spot that I want to change. So this is the 0th element, this is the 1st element, this is the 2nd element. So I would do 2nd element because it's the 80 we want to change. And I can actually just directly assign it to a new value. So now I do grades 2 equals 90. I print the grades beforehand, and then I print the grades afterwards. You'll see the first time it was an 80, second time it's been altered, so it's now a 90. So this is a useful thing to know. And you can do that with multiple grades too. So let's say the first person and the second person. So I use a 3 here because the first person I don't want to include is the 3rd person here, the 0, 1, 2, 3rd person. So let's say the first person actually got 100 and the second person still got that 90. So I could pass in 100, 90, and now I print out that. So you see now I passed in a list, it updated these 2 elements in the list appropriately. Okay, to end this video, let's combine everything we've learned so far in all of these videos, and we'll actually learn one more useful command for lists. So I just want a list. Let's say we have a list of names. So we have names like, I don't know, Ben, Jerry, that's kind of funny, ice cream. I'm getting hungry, I think. Bob, Joe, Xavier, Tyranitar, Shaquavius. I'm just having fun right now. And Keith, my name. And how about one more? We'll add Pegasus. So all very common names. You know, you got Ben, Jerry, Bob, Joe, Xavier, Tyranitar, Shaquavius, Keith, and Pegasus. And I want my function to tell me whether or not Keith is included. So a specific name is included in my names list. So I'm going to just call this function check for name. And I'm going to be able to pass in whatever name I want to check in this list. So it doesn't have to be Keith. It can be any of these names that I put in this list, or maybe your name or anything. So follow along and do this with me. So name. So we're passing in a name. Whatever name we want to check will be held by this name variable. So what I can do, and then we'll also pass in the list of names. So we have a name that we're checking for and the list of names to check. So what I can do is I can say, okay, I want to know if Keith is in this function. So if I can do if name, and there's actually this function called, or not I guess a function, but there's a method that's just in, so in. So this allows us to actually check for an element inside of a list. So if name in names, I can return true. So the name does exist. Else I can return false. So now if I run check for name with let's say Keith, and our list of names that we defined up here, this should print out true. And it did. If I tried to capitalize my name, it would print out false. If I threw in just like a random name, like John Cena, it would print out false because I didn't include John Cena. If I try to search for Jerry, it would be true. So this is a function that allows us to check for names. And also I can actually simplify this function. I kind of wrote it a little bit improperly just to see if you guys would catch this. Instead of doing if name and names return true, else return false, I can actually just directly, I don't even need to use this if statement. I can just directly return name and names. And then maybe that wouldn't be intuitive right off the bat, but this actually still works. So Jerry's in there. Bob should return true. Xavier should return true. Joe with 12 E's should return false. And one final thing, I could also like pop off my name. Stop pop. Or remove. I'll remove my name because I forget what index it is. Keith. And then if I check for my name, it should say false now. Yep, and it did. And if I deleted this line, true. Okay, that's all I got for this video. I recommend playing around and trying to like test out what you've learned in this video. Go to that coding bat website I showed in the previous video. That's a good place to practice all sorts of exercises. I'll be posting the next tutorial video by this time next week. In that next video, we'll cover for loops and while loops, which do a lot of building off of the list that we covered today. Also, in the next video, I'll introduce a game that you can build. So it'll be a separate little video, but we can program our first like fully functional animated game using the skills that we've learned in these first 5 actual tutorials, including the next one I'm going to be posting. So 5 including that next one. All right. If you like this video, make sure to throw it a big thumbs up and subscribe so you don't miss any of the future tutorials. Thanks again for watching. Peace.